Okay, class, we're about to go over the competency test review for fractions. Now, we went over this earlier in class. However, I would like to reiterate some points. Okay, first, number one, it says use less than, greater than, or equal to make a true sentence. Now, we have 6/7 and we're comparing it to 48 over 56. Now, we could use the method that I taught you. We would take this 6 and multiply it by 56. And that would give us our first number. Next, we would take this 7 and multiply by the 48, and that would give us our second number. Now 6 times 56, we could go off to the side and take 56 times 6. 6 times 6 is 36, carry our 3. 6 times 5 is 30, plus 3 is 33. So this would be 336. Next, we would take this 7 times 48, or we could write it as 48 times 7. 7 times 8 is 56, carry your 5. 7 times 4 is 28, plus 5 is 33. So this is also 336. So that means that these values, these fractions, are equal. So the equal sign would be your answer. Now we come here to B. I'm going to draw this little line to separate A from B. So we do the same thing. We take the top of the first fraction times the bottom of the second fraction. So we add 3 times 42. That would give us our first number. Our second number would be 4 times 39. Now, we could go off to the side here and do 3 times 42. Well, I would prefer, let's say we go down here to the bottom. We could take 42 times 3. 3 times 2 is 6. 3 times 4 is 12. So this would give us 126. Now we could go down to the bottom here and do 39 times 4. 4 times 9 is 36. Carry a 3. 4 times 3 is 12. Plus 3 is 15. So this is 156. So this means that the second fraction is larger than the first fraction. And remember, with our inequality symbols, we always point to the lower number. So this is our answer. Now that took care of problems 1, A, and B. Now we come to problem 2. We have 3/4 here. Now, first of all, we have to determine where 3/4 lies on the number line. Does it lie in between 0 and 1 or 1 and 2? Now we notice that this is less than 1, so that means it will lie between 0 and 1. Okay, now, this is our next step. We'll start here at 0, and we'll count till we get to 1. So we won't count 0, but the tick mark right behind it. So we have 1, 2, 3, 4. So that means that each one of these tick marks are broken up into fourths. So this first tick mark is 1/4. The second one is 2/4. And this last one, well, this third one is 3/4. So we will mark our answer here. So that is your answer, 3/4. Now we come down here to B. Now if you notice, B is 3/2. Now 3/2 is an improper fraction, meaning that this would be larger than 1. 2 goes into 3 one time, and you know we'll have 1 left over. So this is really 1.5. So what we would do here is we would know that this goes between 1 and 2. So we'll count from the 1 to the 2, not counting the 1. We'll go 1, 2, 3, 4. So it's 4 places. So what we would do is we would do like this. This is 1/4, 2/4, 3/4, and 4/4. Now we know the halfway mark between this 1 and 2 will be the second value here, which would be 2/4. Now to show this mathematically, 2/4 when simplified is 2 over 2 times 2, because the prime factorization of 4 is 2 and 2. These two simplify out, and you will have 1/2. And since it lies between 1 and 2, we know that that will be 1 and 1/2, which is what we have here. Now, we scroll down here to problem number 3. And I know you don't have to scroll down on your review sheet, but I had to expand this so I would have enough room to write. Okay, number 3. It says, given the diagram below, write the fraction that represents the A shaded part of the diagram. So the first thing we would do is count all of these values inside of the diagram, these blocks. We have 1, 2, 3, 4, 5, 6, 7. So 7 would be our denominator. Now we need to find our numerator, which is the shaded part. We have 1, 2, 3 shaded parts. So our final answer here is 3 sevens. Now we go down here to B. It says the unshaded part of the diagram. It's still 7 parts of this diagram. So your denominator still would be 7. Your numerator would be everything that's left that's not shaded, which is 4. So your answer here would be 4 sevens. Now to prove that this is correct, everything in this box here is either shaded or not shaded. So these two added together should equal 1 whole. And we know 3 sevens plus 4 sevens is 7 sevens, which is 1 whole. Okay, now we get to number 4. It says reduce to lowest terms. We have 18 over 21. Now we simplify using the prime factorization. We have 18, we have 21. So we break 18 down to the prime factors. This will break down to 2 times 9. So we know 2 is prime. This 9 breaks down to 3 times 3. We know this 3 is prime and this 3 is prime. So the prime factorization of 18 is 2 times 3 times 3. Now we have 21. 21 prime factorization is 3 times 7. Both of these numbers are prime. So now all we have to do is substitute for these values here. 18 prime factorization is 2 times 3 times 3. And 21's prime factorization is 3 times 7. We simplify out what they have in common, which are these 3's. And 2 times 3 is 6. And we will have 7 for our denominator. So that is our final answer for number 4. Now we scroll down here to number 5. Number 5 is basically the same thing, except for they want us to express our final answer as a mixed number. So we still start this off the same. We would take 48 and 15 and find their prime factorization. 48, we know 4 times 12 is 48. 4 breaks down to 2 times 2. 12 breaks down to 3 times 4. And then this 4 breaks down to 2 times 2. So we look here. All of the prime factors of 48 are 2 times 2 times 2 times 2 times 3. That's the prime factors of 48. Now we go here to 15. We have 3 times 5. 3 is prime and 5 is prime. So the prime factorization of 15 is 3 times 5. So now we substitute. We have 48 over 15, and that equals 48's prime factorization. We add 2 times 2 times 2 times 2 times 3. All over the prime factorization of 15, which is 3 times 5. These 3 simplify out, and you're left with 16 for your numerator, 5 for your denominator. But we want to write our final answer as a mixed number. So we will go off to the side and do division. 5 goes into 16 3 times. 3 times 5 is 15. 16 minus 15 is 1. So we have a remainder of 1. So our final answer is, remember, all of the integers in front of the remainder, that will be your whole integer or your integer. Your denominator stays the same as 5, and your numerator is the remainder. So it's 3 1/5. Okay, now with problem number 6, I'm going to draw this little line here to let us know everything over here concerns number 6. So we had 6 and 5 11s plus 2 and 9 11s. So we could write this vertically. We had 6 and 5 11s plus 2 and 9 11s. Now, we typically would draw this long line here if we didn't have a common denominator, but we do. So this long line was actually unnecessary. We could add these fractions together. 5 11s plus 9 11s is 14/11. And 6 plus 2 is 8. Now we cannot leave this like this because we have an improper fraction here. So what we need to do here is we need to find out what integer we could pull out of 14 divided by 11 and add that integer to 8, and whatever the fraction is, that will be your answer. So we'll go off here to the side and take 11 into 14. 11 goes into 14 once. 1 times 11 is 11. 14 minus 11 is 3. So your remainder is 3. So now, this right here, we have 1 as the integer. So this 1 would be added to this 8 here. So 1 plus 8, we know is 9. Now the fraction, your denominator would still stay 11, and this remainder here would be your numerator. So your final answer here is 9 3/11. Now we scroll down here to number 7. Now number 7, we have unlike denominators here. So what we do, we find the prime factorization of 4 and 12. 4 becomes 2 times 2, and 12 becomes 3 times 4. And this 4 becomes 2 times 2. Now, the prime factorization of 4 is 2 times 2, and the prime factorization of 12 is 2 times 2 times 3. Now we find the common denominator. We match up these two 2's, we count it once. We match up these two 2's, we count it once. And then we have a 3 left over. So our least common denominator would be 2 times 2 is 4 times 3 is 12. So our least common denominator would be 12. Now to find our numerator, this is what we would do. Remember, we would take the new denominator divided by the old denominator. 12 divided by 4 is 3. Now we would take this 3 here and multiply it by this numerator here. So we have 3 times 3, which is 9. Next, we would take this new denominator divided by the old denominator. So we had 12 divided by 12, which is 1. So we would take this 1 here and we would multiply it by this 5. 1 times 5 is 5. Now we can add these fractions together. Our denominator would stay 12, and 9 plus 5 is 14. Now, we could take the prime factorization of 14 and 12. Now, what's nice about this is we already found the prime factorization of 12, which was 2 times 2 times 3. So all we have to find is the prime factorization of 14. Now, we could go down here, and we could say 14's prime factorization is 2 times 7. Now we simplify out the terms they have in common, which are these 2's. So now our final answer would be 7/6. Now because we didn't start off with any mixed numbers and we were not asked to write this as a mixed number, this is our final answer, which is 7/6. Now we go here to number 8. We need to find the common denominator of 12 and 10. Now 12 we already have from the previous problem. We have 2 2's and a 3. 10 breaks down to 2 times 5. Now we have 2's in common here. We write that once. We have no other 2 in common. We bring that 2 down. We don't have a 3 in common. We bring down the 3. And we also bring down this 5. Now we multiply. 2 times 2 is 4. Times 3 is 12. Times 5 is 60. So our common denominator here is 60. Now, again, we take this new denominator divided by the old denominator. 60 divided by 12 is 5. So now we would take this 5 and multiply it by this 7. 5 times 7 is 35. So now we take the new denominator divided by the other old denominator. 60 divided by 10 is 6. So we would take this 6 and multiply by this 3. 6 times 3 is 18.